Okay, so starting from alkanes, basically we discussed the isomerism of alkanes starting from butane because propane has no isomer. Okay, we start from butane. So we did all the things homologous series. So this is alkane. We know that the general formula for alkane is CnH2n plus 2. Okay, the general formula for alkane is CnH2n plus 2, and alkanes are saturated hydrocarbons. Saturated hydrocarbon means that they are having single covalent bond. That's why. And generally, alkanes are less reactive. You know why? Because alkanes have a single covalent bond, and single covalent bond is a stronger bond. Why single covalent bond is a stronger bond? Because single covalent bond means sigma bond, and sigma bond is formed by the head-to-head overlapping of different orbitals. So that's the reason. The overlapping is very strong. Overlapping is very strong. Head-to-head overlapping. That's the reason. Single bond is very strong bond, and more energy is required to break that bond. So that's one of the reason that alkanes are less reactive. And of course, we will see the less reactions of alkane as compared to alkene. That's one of the reason, okay? So first of all, physical properties of alkanes. So like it's not fixed that I would be saying they are gases, they are liquids, they are solids. No. It depends on the number of carbon atoms. It depends on the number of total atoms. If you remember in chemical bonding, we used to discuss intermolecular force. Intermolecular force depends on two factors. Number one, total number of electrons and the surface area. So if you can see, methane has 5 atoms, 1 carbon and 4 hydrogens. Then you can see ethane has 2 plus 6, 8 atoms in total. This is going to be octane, 8 plus 18. It's going to be 24 atoms. So when the total number of atom increases, so the total number of electron increases. When the total number of electron increases, so IMF increases. Okay. When the total number of electron increases, so IMF increases. That's it. So remember, as the number of carbon increases, so they become solid. So starting, they are gases, and then they become liquid, and then they become solid. So it depends on the number of carbon atoms, depends on the intermolecular force. When the intermolecular force would be stronger, so that's gonna be solid. And when the intermolecular forces are weaker, so I can say they are going to be gas. Simple. And when we have in between gases and liquids, gases and solids, so they will be liquid at room temperature. Okay. So that's why. And if we talk about melting and boiling point, so again, I can say I can't say that they are going to have high melting point. I can't say that they are going to have low melting point. No. Again, it depends on the number of atoms. If they have less atoms, weak IMF. When they have weak IMF, so low boiling point, low melting point. As the number of carbon increases, so the total number of atom increases. When the total number of atom increases, so I would say that the IMF increases. When the IMF increases, so melting and boiling point increases. Okay. So I mean to say it's not fixed. It's not fixed, remember. Okay. And what type of IMF they are going to have. We have discussed 3 types of IMF, if you remember. London force, like it's also known as induced dipole. It's also known as instantaneous dipole. And then we have discussed permanent dipole. And then we have discussed hydrogen bonding. Okay. So since they are non-polar, since hydrocarbons are non-polar, so they only have dispersion force, London force, van der Waals force, induced dipole force, instantaneous dipole force. They don't have permanent dipole. They don't have permanent dipole, okay? So that's the reason, like all the time in alkane, we will be discussing only the ID force, okay? Because they are nonpolar. So you can see, as I told you, they depend on two factors. Number one, a number of electrons, and number two, surface area. So I have given you two examples in which the first molecule is going to have a higher surface area and another molecule is going to have a lower surface area. You can see the structure. In this molecule, we have higher surface area. It's occupying more space and it's occupying less space. Okay. So when it's having more space, so means that it would be having more point of contact between the two molecules. That's why I'm saying IMF would be stronger. And if you can see this one, if similarly I have another molecule of this, so you can see the point of attachment, its minimum attachment. When it has a minimum attachment, so I can say IMF is weaker. When IMF is weaker, so the boiling point would be lower. Again, depends on the surface area. That's why I'm saying it's not fixed. Okay. And then uh, they are insoluble in water. Why they are insoluble in water? I would say that they are non-polar. Okay. I would say that they are non-polar. Okay. All hydrocarbons are non-polar. Remember, all hydrocarbons are non-polar. So, but they will dissolve in organic solvent. You know why? Because organic solvents are also non-polar. So like dissolves like. So like dissolves like. Polar will dissolve in polar and non-polar will dissolve in non-polar. Okay. So, and what about the volatility? What do you mean by the term volatile? Something which evaporates at room temperature. Okay. Something which evaporates at room temperature. So room temperature, like let's say if I have perfume and let's say if the bottle of perfume has been broken down, so you will see that in seconds, the whole liquid will be evaporated. In fact, isn't it? That's called perfume is highly volatile in nature. So when something is highly volatile, what does it mean? It has a lower force of attraction. That's why the molecules, like they are going far away from each other. It's due, it's due to the weaker force of attraction. It's due to the weaker force of attraction, right? Or when something is less volatile, it's not going to evaporate. What does it mean if it's not going to evaporate? Means the molecules are not moving further away from each other due to stronger attraction. So what if I can predict the volatility of these two compounds since I know that IMF of this molecule is stronger and IMF of this molecule is weaker. So when IMF is stronger, so it's less volatile. It cannot evaporate due to the stronger attraction. And if it has a weaker IMF, lower force of attraction, so it can evaporate at room temperature. So it's more volatile and it's less volatile. So volatility is inversely proportional to IMF. When IMF is higher, so the compound would be less volatile. And if IMF is lower, so the compound would be more volatile. So again, I would say depends on the IMF. So IMF is very important factor in this when you are going to discuss the melting boiling point, when you are going to discuss the IMF. So that's very important, right? So Then after discussing physical properties, then we have chemical properties of alkanes. Chemical properties of alkane means that uh, since I told you that they are less reactive because they are going to have a single covalent bond, which is a stronger bond. So, when they will be reacting, so you have to provide more energy in comparison with alkenes, I can say, right? So, you know, it's a very famous reaction. Also, you have discussed in your O levels or IGCSE. It's a free radical substitution reaction. Free radical substitution reaction. So, what is this reaction in which you can see the radical? First of all, what is radical? You know, we have two things, ions and radical. We have two things, ions and then we have a radical. So before going to discuss the radical, I can say that this reaction would occur in the presence of sunlight only or UV light. So the reaction which occur in the presence of UV light is known as photochemical reaction, and especially it's called halogenation. And especially it's called halogenation. What do you mean by the term halogenation? Halogenation means that we may have chlorination and we may have bromination. Like, I mean to say, when hydrogen is substituted by chlorine, it's called chlorination. And when hydrogen is substituted by bromine, it would be known as bromination. Okay? So that's why I am saying we have two reactions, chlorination and bromination. Okay? So, then I can say, first of all, that's the general reaction for chlorination. Like the general reaction says that what would happen if the alkane, especially methane, reacts with chlorine. Okay. If the methane or any of the alkane reacts with chlorine, like we might have methane, ethane, propane, butane, pentane, hexane, heptane, octane. So, I wrote two reactions. Number one, in which I have only substituted one hydrogen by one chlorine. Initially, I had four hydrogen atoms, and right now I have three hydrogens. Where is the fourth one? So the fourth hydrogen is substituted by chlorine. That's why it's called substitution reaction. And especially this is called chlorination because hydrogen is substituted by chlorine. That's why. And if I would be having bromine, so it's gonna be bromination. Okay, makes sense. So when they will be mentioning that excess chlorine I have. So you know what you have to do? All of the hydrogen would be substituted by chlorine. So if I had CH4, then I would have CCl4 because all hydrogens are substituted by chlorine. Like it's mean that we have excess chlorine. And when nothing is written, so you know what you have to do? Only one hydrogen is substituted by one chlorine. That's it. Okay. It's very easy. Then we have to discuss the mechanism. What is mechanism? Mechanism means what? Mechanism means how the reaction would happen, how the reaction would occur, what are the steps, what we will be doing in that. So the very first step is called initiation. What is this? What is this initiation? I have taken chlorine molecule, right? I have taken chlorine molecule since we know that chlorine molecule is having a covalent bond in which you can see one line. This line shows that this electron is belong to this chlorine and this electron belongs to this chlorine. Okay, like that. When the sunlight would strike on this covalent bond, of course, sunlight has particular amount of energy that can be used to overcome the force of attraction between the two chlorine atoms, so the bond would be breaking down. So when the bond would be breaking down, it's called fission, breaking down. We have two types of breaking. Number one, I have homolytic breaking, then heterolytic breaking like fission. For a homolytic, for a homolytic, for a homolytic, they will be there will be equal distribution of electron. Like this chlorine is taking one electron, and this chlorine is also taking one electron. It's called homolytic. It's called equal distribution of electron. And when there would be equal distribution of electron, so radical is produced. What is radical? Having odd number of electron, no charge, very reactive. You can see there is no charge on a radical. You can see there is no charge on a radical, and they are highly reactive. They are really highly reactive, right? And once we got a radical, it will explode in everything. Like let's say like first of all, let me tell you few things before going to do propagation step. We have two types of arrows: full arrow and half arrow. Full arrow and half arrow. When there is, it's called single headed arrow. It's called double headed arrow. So when do we use single headed arrow or a double headed arrow? So single-headed arrow is used for homolytic fission, like that. You can notice, I have done single-headed arrow, because one electron is going towards this chlorine, another electron is going. It's not a pair. When I have two electrons, so I can make double-headed arrow. And when I have single electron, so I can make single-headed arrow. So the concept makes sense, right? So then, as a result of homolytic fission, radicals are formed. And as a result of heterolytic fission, ions are formed. Like I have HCl. So you can see that chlorine is more electronegative. Let's say we are doing business. You have invested 50,000. I have invested 50,000. And like, let's say one day, let's say, uh, on something, I have some confusions. Okay. I have some, I can say, like I'm not agreed so far. So, and now I'm asking from you that give me my amount, or I'm not going to do business with you anymore. So let's say you are stronger, I'm weaker, and now you are saying that I will only give you 20,000. 30,000 is the fine because you are going away without any prior information. So you will be giving me 20,000 out of 50. Like, so I got 20,000 and you got 80,000, right? So same, it's called heterolytic, unequal distribution. It's called heterolytic, unequal distribution. Same goes for this. Chlorine is stronger. Hydrogen is weaker. Hydrogen is a poor man. Chlorine is richer, is a rich man. So chlorine will be taking away electron. This is highly electronegative element. So as a result of this, chlorine would be having negative charge. So when something has a negative charge, it's called ion. It's called ion. And when something has a positive charge, so I can say it's called ion. So I can say as a result of heterolytic fission, ions are formed. As a result of heterolytic fission, ions are formed. As a result of homolytic fission, radicals are formed. That's the main point. Okay. So uh, and this is one of the main point that you need to go through this. Whenever we would be having homolytic fission and when we would be having heterolytic, when the electronegativities are same or similar, so I can have homolytic fission, and when the electronegativities are different, so I can have heterolytic fission. Okay. Now, in the initiation step, we got a radical once the radicals are formed, so they can do a chemical reaction with methane. I have given different colors so that you can understand what's going on in this and where the electrons are coming from, where the electrons are going. So it would be helping you a lot. Let's say this is chlorine radical. Okay, it needs an electron. Every radical needs an electron to complete its to make a pair of electron. Pairs are more stable than the single one. So you know what it would be doing? Chlorine would be taking away this hydrogen with its electron because chlorine needs one more electron to complete its outer shell. So it would be forming a new bond with hydrogen, HCl. The thing is that when chlorine has taken away this hydrogen, so what about this one? Again, radical is produced because this is also called homolytic fission, right? This is also called homolytic fission. As a result of this one, when HCl is produced, again I got a radical. Again I got a radical. Again I got a radical. So this radical will react with chlorine molecule again. This radical, this radical will react with chlorine molecule again. So again this is a radical. Every radical needs to be balanced. It needs one more electron. So it will take away electron from this chlorine, of course, along with the chlorine. Again, you will be getting the radical like that. Again, you will be getting the radical. So in two steps, what you did, hydrogen is substituted by one chlorine. So in two steps, it's possible. In the first step, chlorine has taken away hydrogen. And in the second step, chlorine is attacking on this carbon to make chloromethane. So you have two steps to substitute one hydrogen by one chlorine. So one hydrogen is substituted by one chlorine. It's in two steps. What if I'm going to substitute two hydrogens by two chlorine? Four steps. What if I'm going to substitute three hydrogens by three chlorine? Six steps. What if I'm going to substitute four hydrogens by four chlorine? Eight steps. So of course you need to substitute each and every hydrogen by chlorine. Let's say if I have ethane. Ethane has six hydrogens. So 6 into 2 is 12 because one hydrogen is going to substitute chlorine in two steps. So if we have six hydrogen atoms, we have to make 12 equations. Remember. So what I did for you, I have substituted one hydrogen by one chlorine. And what you have to do? You have to do the same thing with this, same thing with this, same thing with this. So six more equations I need. Can you try? Can you try for another hydrogen? I'm giving you only 1 minute, then I'm going to tell you fast.
सर आप कह रहे हैं कि हम सिर्फ एक मतलब CH से बना है?
नहीं, मैंने मैंने इस हाइड्रोजन को इससे सब्स्टिट्यूट कर दिया। अब आप बिल्कुल सेम काम करो इसके साथ।
सर समझ नहीं है, मतलब आप कह रहे हैं जिस तरह आपने ये सब्स्टिट्यूट करवाया वो तो मुझे समझ आ गई कि आपने
यस,
सब्स्टिट्यूट
ओके,
करवाया। उसके बाद आप कह रहे हैं कि मैं ये कंटिन्यू रखूं चेन?
यस एग्जैक्टली।
अच्छा, ओके।
Let me tell you, it's very easy. I'm going to substitute another hydrogen by another chlorine, okay? And we have to do this thing with the four hydrogen atoms till I get a Cl4. That's the product. So what I did, I have substituted this hydrogen by this chlorine, and the next one is the next target is this hydrogen atom. So this is my reactant so far. Okay, and then what this chlorine is going to do? Chlorine is going to take away this hydrogen atom to make HCl. Again, the same thing. If you will be understanding this, so it makes sense. It's a trend. It's a trend basically, right? It's a trend. Or let's say the same thing occurred in step one, HCl produced, and I got a radical. Same goes with this one. HCl is produced. Then again, sorry. HCl is produced. Then again, I got a radical, isn't it? Then again, I got a radical. And then in the second step, this radical would be reacting with chlorine, just like that. Just like there is a similarity. There is a similarity. So again, this chlorine would be attacking on this carbon atom. It would be forming this bond. And again, I can have another radical. The thing is that this hydrogen is substituted by another chlorine, and then what we have to do, then next this hydrogen, and afterwards I would be having this hydrogen. So one by one all the hydrogen would be substituted by all chlorine. Okay, Madarka, समझ आ रही है?
जी सर, आ रही है।
Yeah, exactly. So it's
तो
a trend
बेसिकली
basically.
जो
So one hydrogen is substituted by one chlorine in two steps. So another hydrogen would be in two steps, then another hydrogen would be in two steps, then another hydrogen would be in two steps. So the total steps you would see eight. Why? Because the formula is CH4. In this we have four hydrogen atoms. So four hydrogen atom means that we are supposed to have total eight steps. So then what you have to do now, like you can remove this hydrogen fast. Then I'm going to show what I did fast.
सर भेज दिया।
You have shown only one step. You have shown only one step. You can see this is my reactant. What I have to do, this is my enemy. I have to remove this. So again, I have taken chlorine radical. You can see the trend. Radical, then chlorine. Radical, then chlorine. Radical, then chlorine. radical, then chlorine. So this is my reactant. I have to remove this hydrogen atom. So chlorine is going to react with this hydrogen to form HCl. Again, I will be getting the radical. That is going to be this one. Then again, this radical is reacting with chlorine molecule. So then this one chlorine is attacking on this carbon atom to make this CCl bond, and again I would be having the radical that it will be used in another step. Makes sense, right? So first of all, you have to react with chlorine radical, and then you have to react with chlorine molecule until you get the CCl4. Until you get the CCl4, and that's it. It's called carbon tetrachloride. So, so it will be continuously forming the different products. If you are thinking, sir, the reaction is ended, no, no, the reaction has not ended yet, because I have so many methane molecules, Can you, imagine that I would be having 6.02 multiplied by 10 raised to the power 23 molecules of methane. I have reacted only one methane out of this. Out of this, I have reacted only one. Only one molecule I have reacted in 8 steps. So a lot of molecules I have, and I don't want to have any reaction anymore. How can I finish this reaction? How can I stop this reaction? So you have to stop the one, and due to that, the reaction was started. Of course, that's nothing. It's only the radical. So if you will be eliminating this radical, so it means that you are going to finish the reaction. But the question is that how can I eliminate this radical? How can I eliminate this radical so that the reaction is finished? So it's called termination, terminating, finishing, termination, finishing. I'm going to terminate the radical. So, what can I do? Radical will be reacting with radical. They will be forming a molecule. The radical has been finished because they need to get paired. When they will be reacting with each other, they will be paired. So means that the radicals are finished. Once the radicals are finished, so the reaction is stopped. So then you will not see any of the product anymore. So the thing is that you have to eliminate, you have to finish the radical. If you won't be finishing the radical, so you can't expect that the reaction would be finished. Right now, only one molecule of methane has been reacted, then the next turn would be for another molecule, then another, then other, and so on. Okay, so how can I eliminate this reaction? So we have to eliminate the radical. And how can we eliminate the radical? The radical can react with radical to form a molecule. Okay, it's not mandatory that you can only react these two radicals. No, it's up to you. You can react any of the two radicals. Let's say if I have taken this one and this one. So that's also works. Nothing. So they will be forming a product. The thing is that what's the criteria? I have to finish the radical. It's up to you which two radicals you are going to react with. But examiner would be asking, remember that's an important reactions. Examiner would be asking about initiation. He would be asking about propagation. He would be asking about termination. What's going on in termination? What's going on in propagation? What's going on in initiation? In initiation, the radicals, the radical has, you can say, the radical was produced in initiation. And in propagation, the radical is utilized. And in termination, the radical is finished. That's what in this reaction is going on. Okay, it's called free radical substitution reaction. Okay, and same goes for bromine. All are same, but bromine, all are same. Bromine, 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 all are same. Nothing is changed, only chlorine is substituted by bromine. That's it. You will never see fluorine, you will never see iodine, only chlorine and bromine. Yes, Madarka, bolo.
सर जिन एटम्स को एक से ज्यादा इलेक्ट्रॉन चाहिए होता है उनका ये हो भी नहीं सकता क्या?
जिन एटम्स को एक से ज्यादा इलेक्ट्रॉन, मतलब मैं समझा नहीं क्वेश्चन.
सर मतलब ये ग्रुप 7 है, ग्रुप 6 या ग्रुप 5 पे?
Okay, okay, okay. No, no, no. This is all. This is fixed. Halogenation. We are discussing halogenation. Halogen means group 7. Halogen means group 7. Okay. Yes.
ओके ठीक है।